Hello, everyone. Welcome to the first ever Aspect webinar. Today, I'm going to be talking about build file generation. Since it's our first time doing a webinar, please excuse any rough edges on how we're running it. I'm here in StreamYard, and so I'm hopefully going to be able to see any comments that anybody posts while we're going through this. I would love to see comments and be able to answer any questions that come up. I'm also going to introduce my coworker Jason at Aspect. Jason is actually the engineer who wrote most of the stuff I'm going to be talking about today, so he's the expert, and I'm the developer relations person, or marketing, or whatever you would call it. So welcome, Jason.
Hello. Thank you.
This thing you wrote is great. Everybody's going to love it, I hope. To be clear, the part that Jason wrote is going to be the sort of last part of the presentation today. So we're going to start off with, I'll bring Jason back when it's time to talk about that stuff and answers from him as well. Cool. All right, so I've got the content here I'm going to present, and you can also go to training.aspect.build. And if you scroll to the very bottom, you'll see a new section I've added for webinars, and so you can get to this content as well. I'm presenting it here from Notion, which we love, but you can get to the same thing through your web browser. I think there's a couple spots where it appears slightly different. And we'll leave this material there, so even when we put up a recording later, you'll be able to get to it and see it there. So as you may have read when you saw the advertisement for this webinar, our goal here is that writing Bazel build files by hand has this configuration language, and that's a barrier for engineers, and I'm going to show you how to remove that friction. So we're going to talk about Aspect CLI and Gazelle, and I will start off with this first section. Why do we want to generate build files? So let's talk about, generally speaking, how to build systems work. So you need to set up a build when you're going to write software. And there's usually this one-time set and forget step that you do. You might have just a wizard or some installer command that comes with the language or framework you're using. Maybe there's some expert on your team who sets up the build system. Then you're going to write a bunch of code, and then at some point you need to add new dependencies. And so you need some easy path for declaring that the build system can make sure that that dependency is installed. In some cases, you just run pip install, and now your machine has that dependency globally. In some cases, you want to install it locally within your project. And if you're using a nice IDE, it might be the case that you add an import statement and it just fixes it for you. That's always been the case. For example, when I've used IntelliJ for Java projects, it knows how to update your pom.xml file, and then Maven downloads the right things. And then at some point, there's like yearly maintenance, approximately yearly. In the case of Bazel, we get a new major version about once a year. So nowadays, everyone's trying to upgrade to Bazel 8. And that always involves some amount of churn and upgrades. And so that's, really the one-time setup is more like a yearly maintenance. So who does these things? Well, typical build systems, you have this setup step that an infrastructure expert can do. And then product engineers are the ones who want to write code, and they have to operate the build system just by, running it. They just run build or whatever. And of course, we've had this DevOps movement in our industry for a number of years now. And so there's more specialization in companies where there's a developer infrastructure team who is responsible for being infrastructure experts. And so the product engineer is a whole different person. It's not just a different persona. And so they may not know much about doing setup and maintenance. And in most build systems, that works great. Why is it easier? Well, those other build systems have mature tooling for when the product engineer adds a dependency. They don't trip over it as much, like my example of IntelliJ updating my pom.xml file. Also, most build systems don't try to be very ambitious in how fine-grained the dependency graph is. And so it's just not that frequent that you need to update the graph. And my argument is that Bazel, at least by itself, is broken in this regard. In fact, it's like a regression from other tools, because we tell product engineers that they have to manually update the dependency graph for Bazel by updating these build files before they can invoke the tool. Like, this is a step that they're expected to do. And those files are written in this language called Starlark. And even though it's like a Python dialect, and so it's kind of familiar if you've done any Python, like it's just scary to say, hey, you have to learn a new language before you can configure your build for the code that you just wrote. And developers don't want to learn a new language. That's crazy. And also, Buck2 and maybe some other build systems have a feature that Bazel doesn't, which is that the dependency graph could be dynamic based on the contents it finds inside of files. So maybe one example is if you run protocol buffer plugin, it might generate some code that you need to know about, but Bazel can't look at the proto file and know that. And so there's no way for it to know that this file is going to be created. And so we have to update build files as a workaround. And so you can really think about, by the time you run Bazel Build, that's not really the first step. The first step was to do the workaround to read the file content and update the build files, and then you can run the build. So that's not great. What do we do about it? So there's a tool called Gazelle. I expect most people who run Bazel have at least heard of Gazelle. So this started internally at Google. The first version of it was called Glaze, which was in Google. Google, of course, has, instead of calling it Bazel, they call it Blaze. So Glaze was like a portmanteau of Go and Blaze. And this was actually part of the rollout of the Go language. I think when the developers of Go, Rob Pike and Russ Cox and those famous folks knew that adding a new language and then making developers do this manual build file editing wasn't the user experience they were going for. Now, when they were creating the Go language, they had Bazel in mind, right? So tasks like resolving import statements, they knew that if the import statement resolution logic was weird and confusing, then that was going to make it difficult to write tooling that could automatically follow import statements and generate build files. And so the language was made with a bunch of constraints that made this problem a little bit easier for Go. And then this was open sourced by Jay Conrad at Google as Gazelle, which is absolutely fantastic contribution that the community depends on. That's now been contributed under the Bazel contrib GitHub org. So that means that the Linux Foundation is now owns this, and it's community maintained and reliable. I mean, everybody who's using Bazel, I think, should be using this. Okay, so I'll talk a little bit about the basics of how build files are generated using Gazelle. Maybe I would love for somebody to post a comment and just confirm to me that it is possible for comments to show up for me. I'm a little concerned that I'm talking to a black box and I don't even know if everyone is here. Hopefully everyone is here. Okay, so build files have been described as like by the people who wrote Bazel as, oh, wow, thank you everybody for commenting. Now I'm excited. That's a lot of comments. Yeah, so now that you know how to comment, please also go ahead and ask any questions over there, and I can see them and also present them in the stream. So what do we mean by bare facts? So you have a bunch of source code and its dependencies, and the bare facts are things that you can derive from the source code. So what are what language is it written in? Is it a library or a binary? Does it have any dependencies, and what are they? Are there some specific, flags that pertain to this code? And so since those things are mostly trivial to derive from the source code, of course, the observation is there's no reason to write these by hand. Like, it's definitely a problem that computers can solve. And so here's how Gazelle works at a super high level, a little hand wavy. So it's like the visitor pattern, which you can take a look at if you haven't seen it before. Let me make sure my Chrome window's over here. Right, and the visitor pattern is basically a tree walk in which each time you visit a node in the tree, you can invoke something over it, and that's basically a recursion over a tree, right? So Gazelle does that. It walks the source tree, and in theory, it should respect the .bazel ignore file. I know Jason's been working on having it respect the .git ignore file and so on. So like the tree walk itself. There's some interesting details. And then as it discovers a folder, it will descend into it unless it was told not to. And I'll show you some directives later about how to skip a folder. If it already has a build file, then it can read special comments there, which are called directives. And those configuration values will now apply. And I'll show some examples in a bit. Then we need to locate some source files. So usually that's file extensions. So like .go is the files we're looking for if Gazelle is trying to generate build files for Go code. And we declare targets that generate what do we find in that code. So those targets, it may be based on how it's configured, where the source files are. We have to look at the import statements that we find by parsing the source code, which is basically the same thing an IDE does to create an index. And then each of those modules can then export whatever symbols it has, which are going to be used later when we need to do dependency resolution. So Gazelle will see this package or target exported some symbols. And so if those are referenced somewhere else, then we will know which target should be added to the depths. So after this tree walk is complete, there's an important thing here, which is, so it does the dependency resolution, and it figures out which attributes should be used. So for example, depth is the most typical one, where an import statement usually will result in a dep on whatever target exposes that symbol. And then, very importantly, it merges the results. And the merging is actually pretty sophisticated in Gazelle. It might create a new build file, or it might edit a current one. But the point is that it's non-destructive. So the idea is to allow hand editing of build files in concert with Gazelle doing automatic maintenance of build files. That's important because our goal here is for most of the build file to be automatically generated, but there are always cases where either developers need to add their own rules, or they need to make custom changes, they need to adjust a value of an attribute, and they want that to be left alone. You can also use this keep syntax to leave even more things alone. So there's a few places this can go. So the simplest one you may see is on an individual line. So in this case, maybe this some package dependency isn't actually referenced in the Python code, but it has to be here anyway. Gazelle will try to remove dependencies that don't seem to be imported anywhere. So the pound keep will tell it to don't remove this one. You can also put it on other syntactic elements. So you can put a pound keep on a whole attribute, and then the attribute will be left alone. You can also put a pound keep on an entire rule, and then it won't manage that one at all. So that can be useful when you need to opt out of Gazelle management for whatever reason. That being said, most of our customers have found that keeps are a smell. And so we don't want to set up Gazelle in such a way that developers have to put keep all over the place. It's kind of like a break the glass feature, but in the same way that suppressing warnings from your linter can make the code read back poorly, and nobody ever comes back and checks whether the suppression belongs there. And maybe really the core problem was that the linter had a false positive. It's sort of the same idea with keep statements. Ideally, the generator should do the right thing. So this all comes from the Bazel Gazelle repo, so you can go check out that repo. It also has some other stuff in it, like it was developed at the same time as the Go generator, so it has some Go stuff built into it, like Go repository. Okay, so let's talk for a minute about how to install Gazelle. In particular, there are two alternatives, and I think this is maybe not as widely known. The first one is to use a pre-built binary, and this is what we recommend. So there's a couple ways to do this. So one of them is that you can have some workflow that you set up in your repo that you build a binary whenever you need to. So essentially, after there's changes that are related. For the right architectures, right, you might need to run Gazelle on more than one machine type, and architectures and operating systems, and then publish that somewhere that developers can use. There's a nice pattern I've blogged about here for running tools installed by Bazel. That keeps opening in the wrong Chrome window, which recommends having a tool/Bazel script as an indirection. And you can use something like rules multi-tool is a great way to fetch pre-built binaries that are outside of the repo. In theory, of course, you could also check in the files into the repo, but it tends to be too big and makes git clone slow. You could use git LFS. There's lots of ways you could set this up. We also, and this is Aspect specific, in our CLI, we have a pre-built Gazelle binary that's just included. And so if you run configure, so you might have this set up as the Bazel command. So you would literally run Bazel configure instead of Gazelle. That's just very convenient because then we've distributed it. We have a number of common language extensions that are built in, and we're happy to add more. Just let me and Jason know what you need. And then you can also, if you're using the Aspect CLI, you can write your Gazelle extensions in Starlark, and I'll cover that for the last 20 minutes or so of the webinar. Cool. So pre-built binaries, and I'll explain why in a minute, but let me show the alternative, which is that you can build it from source. And of course, if you pre-build a binary, you may have this in your repo anyway in order to build that binary. You just wouldn't expect users to run it. But in this case, we're going to tell our users, no, you have to build the Gazelle binary yourself every time you run it. Now, ideally, they have cache hits most of the time, so they may not literally build it every time, but we all know that we build proto-C an awful lot, even though that should be a cache hit. Cache hits in Bazel are best case behavior and not always the typical behavior. So you have something called Gazelle_binary where you declare the languages that you want it to use, right? And these are just labels that point to a Go_library, which implements the API. So like Proto is built into Gazelle, and it should come first because, like I said, each Gazelle extension can export symbols. And so if you need to import protocol buffers from your Go code, then you want the protocol buffer symbols to have been exported already. So the tree walk should visit Protos first, then it should visit the Go code. Here we're using the Gazelle extension from Rules Python. You might also have a Gazelle extension that you write in your own repo. So you mix all those together under the languages attribute. And then there's another rule called Gazelle, which points to that binary. We have the usual stuttering problem where the rule is called Gazelle, that creates a target named Gazelle. It has an attribute named Gazelle. And so if you put this in your root build file, which is where people commonly put it, then users would have to do Bazel run / Gazelle in order to execute the tool. Okay, so why do I say that you should do the first way and not the second way? Well, there's a few reasons. And actually, there was a blog post just this week from Plaid, which I referenced here, and they had a nice explanation of why they decided to always run a pre-built binary. So avoid running Gazelle with Bazel run. Why? So it can add noticeable latency to fetch external repositories if it has to rebuild the analysis cache. In other words, if you didn't manage to get a cache hit. Also, if you have your custom plugin or extension in the same repo, then you can have this catch-22 situation where you can't run Gazelle because first you have to run Gazelle, right? And that's obviously not desirable. Some other things they didn't mention that I've seen as problems with asking developers to build Gazelle from source. So first of all, even if you don't have the catch-22 that they described, even if any build file is broken and it's referenced transitively by load statements that come from whatever package the Gazelle binary is in, that's also going to cause Bazel to error out and not run Gazelle, right? So if you have that Gazelle target I just described in your root build file, anything that's reachable by load statements from your root build file has to at least correctly analyze under Bazel, or Gazelle won't be able to run. The cache hit problem gets worse when you have custom extensions in your repo, because anytime you check in a change to those and developers rebase over that, then obviously they're going to get a cache miss and have to rebuild the whole binary. This can cause you to be careful about like, oh, well, I don't want to land 5 different changes over the period of 2 days to my Gazelle extension because all my developers complain when I do that because they have to rebuild Gazelle 5 times. So let me wait and like land 1 big PR instead. That's obviously against the principles of continuous delivery. The Go toolchain is it okay to make people compile Go code? It typically works fine. Rules Go has always been high quality, but as soon as the CGo toolchain gets involved, it's not hermetic, unless you like go to some efforts to set up toolchains LLVM or something. So that means extensions that need to use CGo, like Rules Python, are going to just not work on some people's computers. And there's like a great PR here from Linji, from Zhongpeng at Uber, working on fixing this problem in Rules Python to use something else to parse the code, because it so happens treesitter is what introduces the CGo dependency. And if you're interested, you can see that like, oh, actually, it's hard to correctly parse Python code this way. It turned out to be a dead end. I think it's great to have, this is just a problem with asking people to compile things from source, right? Is that the tool chain and all the dependencies have to work. And then, of course, if there's no Go code in your repo, then Gazelle is now the first Go program that you're asking developers to build. And they're like, why am I downloading a Go tool chain? I got a comment here that, does it support C++? Yeah, I'll talk about Gazelle for C++ in a minute. Okay, so one other thing about installing it is that you want to check on CI that Gazelle has been run. So it's nice that developers can run Gazelle optionally, but you probably want your repo to be what I would call Gazelle clean, which is to say Gazelle doesn't have any suggested changes to make. The reason being that you don't want somebody later who runs Gazelle to pick up a bunch of changes that are not related to what the code they're working on, and then they send a PR and it has a bunch of spurious deltas that they didn't mean to make. That was like related to somebody else's change that landed earlier. So you can run a CI step. If you run, we usually make a target called like gazelle.check, which uses --mode =diff. It so happens Gazelle exits non-zero if it wants to make a change. So that's an easy way to have a step in your CI that fails, as long as you've set up CI to honor exit codes. Obviously, Aspect, our company, already has a system called Aspect Workflows, which is a turnkey CI/CD platform, and so we just have a task that's built in that says, yeah, I want to run Gazelle. Okay, so let's look at what languages are available. So I mentioned Jay Conrad wrote this at Google. It was originally just for Go. And then also protocol buffers was added because, of course, if you work at Google, you can't not do protocol buffers. And so that was kind of a necessary ingredient from the beginning. Jay added this language interface, and you can go see the details here of the Go code. So like this is what you would need to implement if you wanted to add a language, and a number of people have, right? So there's more languages than just Go. So Go and protobuffer built into Gazelle, Aspect, which is really to say JSON, added Kotlin and JavaScript/TypeScript. There's a couple of these in Bazel Contrib, including Python and Java. There's a few others, Haskell, R, Rust, Starlark, and Swift. I haven't necessarily tried any of those last 5, and so I can't tell you whether they work really well or not. Obviously, in open source, there's a wide disparity in the quality, maintainability, and support for different packages. So why aren't there more Gazelle extensions than just these? I mean, Bazel works with dozens of languages are popular. Well, I think there actually are a bunch of Gazelle extensions. The problem is that nobody's open sourced them. There's a lot of companies that have written these and not provided it. Obviously, one reason is just that it's annoying as an engineer to have to go spend time tracking down like legal permission to open source something. But I think there's also a more practical consideration, which is that it's really hard to generalize one of these to support everybody's conventions. Like there's a lot of different ways to write code and a lot of different ways that might materialize in build files. And you don't want to publish a package that works for you, and then a bunch of people make issues on your repo and say it doesn't work for them. And you say, well, I didn't sign up to make this work for everybody. Right? And now you've made open source, but it's kind of hurting your company's reputation because it doesn't seem like it's well supported. And anyway, having the extension in your own repository is pretty great because you can actually go ahead and modify it to have local conventions for your repo. You can stamp out your own custom rules at the same time that you're stamping out the standard rules for that language. And so having extensions in your own repo is pretty useful. So that's one of the reasons that I'll show that we did it in Starlark. Okay, so to write your own extension, I'm not going to talk a lot about this. A few people have mastered this. I'm not really one of them. You go to this. There's some documentation over here on the Gazelle repo for how to extend it, and you learn the API, right? And you figure it out. It's pretty hard because that API wasn't. I would say it probably wasn't meant for a wide number of engineers to use. It's low level. It's pretty awkward. I've heard that at Uber they actually have their own alternative API to write extensions because they didn't want to use this one. There's no opinion in the API about parsing sources, so there's a lot of different techniques for doing that. Basically, it's just not helping you very much. There's a lot of draw the rest of the owl yourself. You need to learn Go. Not everybody knows Go. And then of course now you have the dependency problem that the depths in your Go mod file are now a mix of the application code and anything that's for your extensions and anything that's for third-party extensions. And so you sometimes have to deal with conflicts there. Also, if you're writing an open source rule set, we've had this problem. There's a distribution problem because you don't want your core library to have a dependency on a Go tool chain. And so both Bazel Skylib and Rules Python have this separate Bazel module that's just the Gazelle extension. And now those two things, like, do they have to be version aligned? It's hard to tell. And the publishing semantics in those repos is more complicated because they have to publish more than one module. And so that's all been rough. Okay, I'll come back and grab a question. So would you recommend Gazelle to make changes, Gazelle check to add it in pre-commit? So pre-commit is an idea of asking developers to wait when they run git commit. My take is that there's a general consensus that you can't make them wait for more than a very small fixed budget of time. So if git commit takes a second or two, that's fine. If it takes 20 seconds, developers hate it. Jason's been working on some stuff to make Gazelle faster. If Gazelle is fast enough for you, then sure, you could put Gazelle check in your pre-commit. I typically haven't, because it's hard to make guarantees that it's fast enough. But I think it's not a bad practice. Clearly, it's better for engineers to discover that they should have run Gazelle before they send their PR than for them to send it and go get coffee and then discover 20 minutes later that they're tested and run because something was, obvious that they could have done themselves. Gazelle and Nix, yeah, I don't have a lot of possible to work Gazelle on Nix systems. Yeah, I think it works fine. I mean, I don't think it actually Nix interacts with this, right? Gazelle's just some program that needs to be built and then it updates Bazel's build files. I don't think it really cares that you have Nix there. I'm sure Nix can help you to have a more, if you're in a Nix shell, then you have fewer problems that I described earlier with compiling CGO code, because you'll be more assured that you have a working C++ toolchain. Okay, so we talked about how to install Gazelle. So now how do you set it up? So there's some configuration steps. So directives are special comments that go in a build file. Most of the configuration is going to be using these. As I mentioned during the tree walk, when we descend into a folder, the directives are discovered and then they apply. And then when we exit that folder, when we pop that off the stack of the recursion, those settings are discarded, which means that the directives apply to that package and any sub packages. And then sub packages obviously can override settings. There's a ton of directives that are built in. I didn't actually link to them here. You can find them pretty quickly on the documentation site. Unfortunately, there's a mix in here. Some of these are specific to Go because Go is built in. It was sort of a historical accident. The ones that I think are the most important to know are exclude, which means I have a directory that it's just not ready for Gazelle yet. Usually when you first set up Gazelle, you're going to want to roll it out like one piece of your repository at a time. So you might exclude like everything but a folder to start with, and then slowly remove excludes as you have things up and running. If you need to do map kind, lets you say, hey, anywhere that I would see that I would try to add a Go library load statement to a build file, instead I want to get it from my own macro. This is pretty helpful because I think a lot of the time it's useful to have a very thin wrapper macro around rules where you can set default attributes that should apply to your repository. And so this way you can make sure Gazelle stamps out the load statement from your macro and not the one from the upstream rule set. Resolve is also super important. As much as, I mentioned how the Go language was developed at Google to make it easy to resolve dependencies, but a lot of languages have very confusing semantics about where to resolve dependencies. Like Python, if you load from, a folder, if you load from some symbol and you have a folder of that name and also a third-party library of that name, then you might just resolve to the local folder instead. So basically, you can say for this language, if you see the following import in my code, I actually want you to get that symbol from the following label. So this tells it what dep to add. And then, of course, there's a lot of directives that come from particular languages. So, for example, if you're doing Python, you will come over here and see all of these directives that apply specifically to Python. Python generation mode, for example, is commonly used. There's a separate, right, they mentioned resolve here, which is the same one I was just talking about. For our JavaScript extension over here on Aspect's doc site, you can see the directives, the directive reference for how to affect the behavior of the JavaScript generator, and so on. So you would expect for every language that they would document their directives. I'll quickly mention that directives are kind of a workaround, right? So if the source code is missing something, the source code doesn't sufficiently describe what needs to happen, then you add directives to tell it what to do. But there's an alternative, which is you can introduce new syntax in your source code that's load-bearing. And so that way, all the information that the Gazelle needs about the dependency graph stays in your source files. In particular, I think that I'm a little bit allergic to the idea of having load-bearing comments in a build file, especially when they start to get long and complicated. Like you'd imagine trying to encode some configuration as a string that goes into a comment. Doesn't have syntax highlighting and a bunch of other things. So one random example here, TypeScript has this thing called / directives, which is basically a way to take something that in JavaScript, you're allowed to get dependencies sort of ambient, like JavaScript started in the browser, and you could just refer to window.document or something without declaring where that comes from. And so TypeScript added this way that looks like a comment, but it's actually adding syntax to the file that says, I depend on something at this path, or I depend on this standard library. And this is useful because now the build file generator can find these things, and so they can live in the file. And you could actually invent your own load-bearing syntax. Of course, the caveat is that the Gazelle extension you're using has to know to look for that thing. It doesn't just, you can't just add random syntax to your sources. You then have to teach the build file generator to read that syntax and know what to do with it. Okay, cool. So we're halfway through the time. That's about right. So let me introduce this work that Jason's been doing. Maybe I'll bring Jason back on the screen. Hey, Jason. Jason, I assume you can see the comment stream going by too, if there's a question you want to answer.
Yes, I can.
Cool. Okay, so I will do my best to explain Jason's work. So this is specific to the Aspect CLI. What we've done is written our own Gazelle extension, which internally we call Orion. And what it does is it wraps a Starlark interpreter, and then that Starlark interpreter exposes this API that can plug in extensions that you write in Starlark, and then we adapt them to be used by Gazelle. And this fixes a bunch of problems that I've been talking about so far. So you don't need to learn Go. You write in the same language that you have for macros and rules. So anybody who's using Bazel will know the language. Anybody who's configuring Bazel, at least, if you're one of these developer infrastructure personas, then you probably know this language reasonably well. I like to think of macros a little bit like they dynamically generate some rules, and Gazelle extensions statically generate some rules. And so they're really kind of two sides of a coin. So another nice thing about these being written in Starlark is that you can port between them, right? So if you have let's say you have a macro today that's called like my abstraction, and what you want to do is sort of a conceptual inline macro refactoring, like you want to get rid of the macro and just stamp out the three things that it creates into build files, you would just port that macro to a Gazelle extension written in Starlark, and it will just generate those three things. Also, of course, you can share code. So there's a lot of logic inside of rule implementations, and now that logic can be used both by the rule implementation and by a build file generation extension that goes along with that rule. Starlark is a pretty good language. Like, it was developed for Bazel to do things just like this. So it's interpreted, nobody needs to compile it. It's fast and really parallel. It has frozen data structures, and it doesn't permit recursion and other things that allow it to do work in parallel. And so Jason made a lot of use of that. So we do things like parsing all of the source files and querying their ASTs, which I'll talk about in a minute, using as many threads as we feel like, right? And you don't have to think about that as the author of one of these extensions. Usually Gazelle extensions are like these big things. Like I showed earlier, a Gazelle binary target that had 4 languages in it. That's like a typical number. But when you're writing these things in Starlark, you can actually just afford to have a bunch of them, and each one does a smaller job. So like we have one customer who's been using this for the longest. They actually also sponsored this work, so thank you very much. They have 29 of these extensions in their repo. You don't have to rely as much on directives, right? Because now instead of having to configure it, you can just change the logic exactly the way you want it to be. And these .star files, the Starlark files, we don't do this yet, but in theory, we can start to distribute these along with the Bazel module. So it solves that distribution problem I described earlier, where rules Python and Bazel Skylib have to distribute a separate module with their extension. That won't be true anymore. Let's fix the syntax highlighting. Okay, so I'll quickly run through how to write one of these, and then I'll show some examples. So you can put this Starlark source file anywhere in your repo. In some cases, yeah, there's not a prescription of where you put it. We like to use .star just because it's part of GitHub's code highlighting to know that that's a Starlark file. We don't put .bzl because this is not actually, it's not the Bazel Starlark interpreter that's going to read this file, and you don't have the usual Bazel built-ins available, right? This is just vanilla Starlark. Next, you're going to register some rules that you want to be able to manage. So you want to be able to stamp them out or edit their attributes. You have to declare that. There's these 3 attribute lists built in. They have kind of funny names, but it's because this system is a Gazelle extension. It needs to, like, once we're done figuring out what we want to do, we hand it back to Gazelle to do the merging. So Gazelle will do the merging of whatever rules were created by Starlark extensions, along with the ones that come from the Go extensions. So these things play together nicely. So there's non-empty adders, mergeable adders, resolve adders. There's the description here of what they do. It's not super interesting. So it so happens that, for example, if you wanted to stamp out SH library targets, as of Bazel 8, of course, you're all getting these from rules shell now because they're not built in anymore. And sources is non-empty. So you should delete it shouldn't be deleted even, I forget why. If present, disqualify it from being deleted. Yeah, so never delete the sources attribute. It's mergeable, and then the depth should be resolved. Then you're going to register your extension. So there's a register configure extension. It's named that because the command is aspect or Bazel configure. So it takes 2 arguments. These are 2 functions, and it's like that so that the caching and parallel execution, parallel evaluation can happen. So prepare is a function that we can run ahead of time and cache the results. You can see the example here, and we're using Lambda syntax, which has been in Starlark for a while, so you don't actually have to make separate functions if they're small. Takes the configuration object as the argument, which comes from the YAML configuration file that you use for Aspect CLI. And then it returns a prepare result, which in this case is very simple. It's just I want to operate over all the .bash and .sh files that you find. Then the other function is declare. So this is called later on, and this is which targets do you want to add? And so again, you can use a Lambda. This is simple. It takes a context object, which gives you something like ctx targets.add. Of course, this API was designed to sort of follow the principle of least surprise. So if you've ever written a Bazel rule, it doesn't look too foreign to you. So in this case, we're saying, oh, we're going to make an SH library, and the sources is going to be the path of each of the sources. So typical sort of Starlark looking list comprehension. And that's literally it. So like this is, of course, a very naive example for writing shell library rules, but this already works. You can see a full-featured version of this over here. And you can follow the links from the training material if you want to read through this yourself. But to do this for real, we actually want to be able to generate SH binary and SH test, which means we need to figure out whether the thing looks executable, which I'll talk about in a second. And then we might have just some simple Boolean logic to decide what kind of target do we want to create. We might want to make a test or an SH binary, and figuring out the name that we want to use. So you can control all this logic for what you want to generate into your build file pretty simply in Starlark. And I'll step through a bunch more examples. So cool. So let me show the different ways that you can query. So I said one of the things we want to do is look in the source files, and we obviously need to find the import statements or anything else about the source files that informs what the corresponding build file should look like. And so that was inside of prepare result. And you can see all the documentation for this over here on our doc site. So I'll talk about these first 2, AST query and regex query. There are a few other queries you can do. And some utility functions that look very much like you'd expect. We're filling in the bits because there's no Bazel standard library here for the Starlark interpreter. So regular expressions, I like to say regular expressions work great until they don't, which is to say, like, we all know about regexes that have gone horribly wrong, and we've all tried to parse HTML with the regex in our career and learned not to do that anymore. However, like I said, we're trying to be practical here, and there's a lot of times where there's really not that many different patterns that appear in your whole repo. And if there's 5 different patterns in your whole repo, you don't need to write something generalized. You're not trying to open source something that works for everybody. So I often start with a regex and then just be very aware of when you've outgrown the regex. So the example I was just showing a minute ago, if we want to tell whether a shell file looks like it should be executable and therefore it should be an SH binary and not an SH library, we can just check and see if there's a shebang line in it that looks like something like this. So .*sh, that looks like it's probably a bash or an SH file that has a that should be executable. Right, so like it has an interpreter line basically built in, and the interpreter is bash or sh or something like that. Okay, so now what happens if you outgrow the regex, which of course you will do at some point, and if you're writing a heavy, a more thorough extension that is meant to be open source or meant to cover a lot of cases, you'll want to use a proper AST querying, and so we're using treesitter. Treesitter is fantastic. I think it came from the developers of the Atom code editor, and so it is built exactly for the purpose of indexing code. It's written in C++. It's bare metal speed, and it has a way to express your AST searches and matches, and it works for basically all languages. So it's kind of perfect for our purposes here. So I'll show this online playground that you can use. Last time I did one of these, I found that now that we have AI assistants, this is a great use case for those. You can just say, hey, give me a tree sitter query that's kind of like this, and it'll give you something that's wrong, but not too wrong. And then you can fix it from there. We've built in a bunch of these grammars, by the way, and essentially we want to add all of the tree sitter grammars. Like you should never encounter a situation where you're using the system and the grammar that you need isn't built in. Please let me or Jason know. We added Java, a couple weeks ago, actually, while I was working on this example. So here's the playground site. You can go over here and play with it. So you basically paste some code, and I think you have to check this box. So you can paste some code and also a query that you want to run over that code. So here in my example, I wonder if I can make this bigger. That's not bad. Okay. So, so the code here has some basic Java, and my goal is to find the main class, find classes that contain a main method and find out their names. This is something you have to do if you want to generate Java binary targets, right? And so my query here, it's a little long, but like it's basically, follows the abstract syntax tree, and it helpfully gives you the tree down here. So you can see, okay, class declaration is a node. It has modifiers. It has a body. I happen to love this stuff ever since I wrote error prone. I've been obsessed with ASTs. So maybe you don't love this, but you'll get through it. Right, and so we have things like, okay, it should have a void return type. It should have a method name, and that method name should be main. It should have modifiers that are public static. Yeah, it looks like Lisp, right? Lots of parentheses. This is whatever. That's the tree sitter expression language. And then after it runs, this class name you can access from the calling context, right? And so when you come back to the Starlark code, you'll be able to say, give me the class name that matched. Okay, so those are some ways that you can query the code. So I'll show a few examples. I'll try to leave at least 10 minutes for questions. So I'll go a little bit faster through this. So one thing we can do is port implementations from Go. So Jason did a couple of those. BZL library is the first one. So I mentioned that the Bazel Skylib project has this generator built in. Pretty easy. It's to port that. It has an AST query because Starlark is one of the grammars that tree sitter understands. Sorry to be a little bit recursive here. We're running Starlark that's going to run tree sitter that's going to parse Starlark that's going to find load statements. Right, so we're looking for things that are called load, and then we can get the name of the thing that they load. And if you're curious, you can see the full code listing over here. It's fewer than 100 lines to correctly implement the build file generator for BZL library. It's a pretty simple one. More complicated example is Kotlin. So Jason wrote this in Go first, and then ported it to Starlark afterwards. This one's still under 200 lines. And there's an interesting thing to note here, which is that this Kotlin, of course, is a JVM language, and so it depends on dependencies that it can get from Maven, for example. And so this file is going to depend on also we have the ability to parse the rules JVM external description, the Maven install.json, and find out where the third-party library symbols come from. Jason, is there anything I should add about that, do you think?
One interesting point is the Maven part of it also works with Java. So now Kotlin, and if we wrote a Java extension in Starlark, they would share the same Maven extension, essentially.
Right. Yep, and also knowing which things are built in is always required. These are things that you might see in an import statement, but do not require anything to be added to the depths. Every language has one of these lists.
One other interesting point is this required significantly less code than doing it in Go.
Mm-hmm. Yes, I have the Go version. You can see the code for the Go version is over here. I didn't try finding out how many source lines of code this is, but I'm sure it's many hundreds. Yeah. Anyway, you can browse through that if you're interested to compare the Go implementation with the corresponding Starlark one. Okay, a couple other examples. So you could also you could build a new language from scratch. So here's one from one of our buddies at a customer site that does post CSS. Again, this isn't necessarily super mature. It worked well enough for the repo where it appeared. Here's one for C++, which was requested earlier. So This one, I wrote this. It's rudimentary, and it has a couple of hard-coded dependencies here. So like SQLite and Google Test, I've hard-coded where those come from. Again, this isn't generalized, but this is great because this was quick and it worked for all the cases I had in the repo. And because it's in Starlark, it's pretty quick for a developer to add another couple lines here. Like if they, as long as they can read and understand this, they can just change this file, add more special cases. And eventually you might get to a point where you make this more mature. I've also heard some talk that there is somebody working on a proper, like an implementation in Go of the C++ extension. So maybe you only need to use this as a stopgap until something better exists. Okay, let me briefly describe testing. So there's this great test fixture that uses golden files. This test fixture works both for Go and Starlark, although as I noted here, we haven't yet released a Gazelle binary from Aspect CLI so that you can write this kind of test for your own Starlark code. We'll get to it at some point. So a test fixture has a workspace file, it has build.in, which is sort of the before, and then it has build.out, which is the after. So Gazelle should read build.in, it reads all the other files in the package, and then this is the assertion, build.out is the expectation. So here's a little toy example. Imagine you had some JSON files. Imagine in your repo, you're going to write your own code generator. So you have a rule called x_lib that generates code from your JSON files, and you want to have a build file generator for that. So this first JSON imports b and lib/l. And then here's b, which just imports lib/l. Build.in is empty. Build.out is the expected what should be generated. So you can see that A has these two dependencies and B has only this one dependency. And then in that same directory, in this case, we have the .star file, which is the thing under test. So like we're testing that this Starlark extension will transform this build.in into this build.out. And of course, you would have dozens of these little folders, each one of which is a test fixture that expresses one of the things that your build file generator should do. Okay, I think this is probably the most important part. So if you're a little sleepy, you should wake up now. Like I said, okay, so let's say somebody does write the C++ extension in Go, and it's high quality and it's open source, and you can just plug that in. Are you done? Well, in practice, even though an extension exists for your language, it probably doesn't cover everything you need it to do, right? And so it's hard to extend them. If you wanted to extend a Go extension, you could fork it and then bring it into your repo, and now you have all the problems of forking code, which is to say you broke it and now you bought it. Or maybe it has directives that it exposes, but most of these extensions have very few directives. They don't cover most of the cases that you might need. And so what you can do is you can have both. You can have, let's say, the JavaScript extension that Jason wrote that's in Go and covers a lot of cases, but then there's cases that you want to cover, so you write your own Starlark extensions to cover some extra things. I have a bunch of examples here. So let's say you're using the Go, you're writing code in Go and you want to have OCI targets next to each Go file that has a main. So you would write a little extension that looks for, in this case, we're just using a regex, and looks for a main. And if it finds one, then we can add a Go image target, which comes from rules OCI. In this case, it looks like we've decided that there's a wrapper macro. So in this repo, we want it to come from //tools OCI. Very similarly for Python, if I have a Python main, I want to generate a Py3 image target to put it into an OCI container. In this case, we're doing something where we say, oh, actually, not every main in our repo should have an OCI container. So maybe in our case, we're going to say, hey, it has to have an OCI :build comment in the file somewhere. This goes back to what I said earlier about adding load-bearing syntax into your source files. So this lets us, instead of putting a directive in the build file, right inside of the main, we can say, oh, and this should have an OCI build for it. And it will stick a Py3 image next to it automatically. Here's an example from JavaScript land. So in this example, what we want to do is look for package.json, use a JSON query to get the scripts. Scripts is sort of the common way that JavaScript developers encode their usual developer workflow. So like they might have a run script that's like, I do npm run. So we can read those scripts, and for ones that satisfy a simple condition, so if it says node space something, then we understand what to do. We can generate a JS binary target for that. Again, this isn't general. This doesn't cover every case. Maybe this covers the cases that I had in this repo where I added this. linting, I wrote rules lint. I don't think that you should put lint targets into your build files, but that's kind of my opinion. A lot of people want to have a test target that appears in the build file that runs the linter as a test. So you could easily generate, let's say you have Python code, you could generate a rough test target next to every py_library. Even though you're using the Python Gazelle extension, it doesn't do this, and it shouldn't need to, right? You can just write a little Starlark extension to do that. You might scan your repo for a specific configuration file, so like webpack config or jest config. If you come from JavaScript, you've probably seen these kind of config files. And then you might generate a corresponding rule like a webpack bundle or a jest_test, because these configuration files are the clue that that tool knows what to do if it runs in this directory. You might do something cool to look for certain patterns in a source file, and then maybe like generate some custom targets that extract stuff. So internationalization is a great example. I haven't wired this up yet, but I think this would be a great example for somebody to build. So like for Go example, there's an i18n library. What you want to do in this thing is you like parse your sources and you look for something in your Go code that has like, where is it here? So if you see like an i18n message, that means you want to extract this thing so that a translator can translate it, and then they'll check in the translations into a file in your repo. Right? And this thing, according to the instructions, it says that you should just run their tool. You should run this extract tool on each directory. Well, under Bazel, you want to have a rule in each folder to do that, and so that would be a great thing to write in this extension system. Copy to bin is another example we've seen at a customer site where rules.js wants to have these rules, and you can just scan for all the sources that match a pattern. One note here is if you have custom Go extensions and custom Starlark extensions, we don't yet give you a way to compile those together. Take a look at this issue 938 over on the Gazelle repo. What we really think should happen is that extensions should be providable at runtime that don't have to be compiled in. Recently, we did some experiment with WebAssembly, which seems like a really promising, lightweight way for Gazelle extensions to sort of be shippable in binary format and loadable at runtime inside of a pre-built Gazelle binary. So that's our long-term plan to make that work. Case study. So we had one customer did a rule CC extension, which is the one I showed earlier, actually, and some happy feedback here. And we would love to get more feedback from anybody else who's already started using this thing. And so with that, we have a few minutes left, and I would love to take any questions. Please don't make us sit in silence. Put some questions into the comment box. While we're waiting for questions, is there anything, Jason, that you feel like is useful to add?
One thing I thought of when you were showing those examples that had, I guess, libraries hard-coded into the Starlark files, note that all the regular Gazelle extensions work, or all the regular Gazelle directives work. So you could also do that with resolve statements in your build files.
Right. Yes. At a higher level, I didn't explain that at all, but yeah, the directive system, we don't mean to fully replace it. So like you could have a mix of directives that are comments in your build files and continue to read those, which works because this Starlark interpreter thing is itself just a Gazelle extension, right?
I think it often depends what are conventions within your repository versus exceptions where you have to write an individual resolve statement.
Here's our marketing page for this, by the way, which just went live, and it's got our little cute Marvin robot doing build file generation.
And again, I'll point out that when you write your own Starlark extensions, you can put your repository or your company's conventions in that extension. So unlike like the generic Go or JavaScript Gazelle languages, which have a lot of configuration to handle different organizations' conventions. And those configurations can get ugly with Gazelle comments to configure everything that could be customized in different organizations. Being able to write that within the generator itself is much cleaner.
It's worth pointing out, I saw that one of the Rules Python maintainers, Agnos, put I think a discussion or an issue on the Rules Python repo saying, we need help maintaining the Gazelle extension. And I think this notion that it should be generalized enough, and it keeps like there's constant feature creep as everybody who uses it needs to add some directives to cover their case. also makes it much harder for to like have maintainers stay up to date with all those things. Oh, this is a great question from Florian. Thank you. So why write build files at all? Yes, in fact, that Plaid blog post that I just mentioned, I think they said one of the things they do is what they call ephemeral build files, where you don't have to check them in. If Gazelle is fast enough and can generate 100% of at least some of your build files, then in theory, every time you run Bazel, you could just generate those build files, put them, in some place that Bazel shouldn't have to look. And I think there's like technically a -- package path argument to Bazel, which allows the package to come from a different location on disk than the sources. I haven't really played with this recently. You could also maybe imagine Git ignoring them or something. Then yeah, you wouldn't. Then you could imagine not checking in the build files. And I think that's a great North Star, and it would be great to get to that point. And of course, it doesn't mean that 100% of the build files have to be that way. You could check in a few build files that have overrides, in any cases that don't require checking them in. You could just let them happen dynamically. Oh, thanks. There was something from BazelCon Community Day. Thanks, Florian. That's a great. Yeah, I should watch that. There's a YouTube link here that anybody watching, you might be able to follow or take it from the comments. More questions? Okay, thank you all for the nice feedback in the comments. We are pretty excited to be able to do this. I know that maybe I'll admit that part of the design thinking here was that I spent so much time doing just Bazel that I don't remember how to write code in any other language. So I said to Jason, hey, I would love to go to our customer sites and make it possible to do build file generation, but I only know Starlark. Can we just do it in that? And yeah, I mean, it's a lot of fun to wire these things up. At least I've had fun doing them. So I guess maybe a good question, or I'll ask Jason a question. Where do you want feedback from folks about things that are missing or questions?
I'll definitely take feedback on the Bazel Build Slack. I'm not sure if you have another location you'd like community feedback on. The Aspect CLI repo is possible.
Yep, the issues on the Aspect CLI repo would work too. Great.
But feel free to message me on Slack.
A question about the recording. Yes, we will figure out where to put the recording. I think it's being live streamed to YouTube actually, so I think it might just automatically show up. There was one more question here. How does it play with cross compilation and multiple platforms? That's a great question. I think in all the cases that we've been experimenting with this, we basically have a rule that's like rules OCI, for example, has multi-arch, the ability to make multi-architecture OCI container images. And we usually have a rule that says like OCI multi-arch and it lists the architectures. You could easily make a Starlark generator like this that generates those. I showed the thing to create like a Go image earlier. You could just add a couple more things to the generator that says also next to each one, put a multi-arch. Cross compilation in Bazel is really mostly just a matter of having a transition on a dependency edge that transitions to the target architecture. So as long as you have rules that understand transitions, like you just need to have the build file generator can just generate the rules that do those transitions. Yeah, and like Florian says, you might need to have like a platform specific, stamp out names of rules that have the platforms in them. But that's, again, pretty trivial to do with just like a for loop in Starlark. Different code for different platforms. I think the answer there is that what we really want is developers on Mac and Linux agree on what build files to create. So I think my naive answer to that question is it wouldn't be desirable to have a different result depending on what platform you're on. But maybe the question is, can I generate code that targets multiple platforms? And then that's the answer we just gave, is like, yeah, of course, like anybody should be able to generate a build file that is that contains platform-aware attributes. Great. Well, we're at time. Thank you so much, Jason, for coming and answering questions. Thanks, everybody, for attending. This was a lot of fun. We should definitely do some more of these webinars soon.
Thank you.
See you all later.